Okay, Trig, this is section 4.1. I'm only going to get maybe about halfway through this, but I think I'll stop after, what did I say I was going to stop? Maybe after example 5, I'll stop. That's about halfway through, and we'll finish the rest probably on Friday. But introduction to polynomial functions, this is kind of the direction that we're going with chapter 4. So polynomial functions we've been dealing with this entire time, but we maybe haven't called them polynomials. Each one of these 4 is an example of a polynomial function. This one's not surprising, neither is the cubic one, but this one is the one that gets people. Like just the number 12, that would be like y equals 12. That is technically considered a polynomial function because that's like 12x to the 0 power, okay? So that is a polynomial function. This one is also. The leading coefficients, the constant term, the degree, they have all of those here. So the degree is the highest power. So here it's 7. The leading coefficient is the number that's associated with that highest power. So 6 is in the front. And then the constant term is the one that doesn't have an x on the end. This second one, so the highest power is 3 because it's really the only power. Leading coefficient is 1 because there's a 1 in front. And the constant term is 0 because there's like plus 0 on the end there. Okay, this guy is degree 0 because he's x to the 0 power. Leading coefficient is 12 and the constant term is 12. And then this last one, they tried to confuse you here because they have 0x to the 9th power, which really doesn't do anything. 0x to the 9th power shouldn't even be in there because it's nothing. It just doesn't mean anything. So really, if we go in order, and these are not in order, x to the 8th power is the next highest. So the degree should be 8. That leading coefficient is 1, and a constant term is the one without x, so that's negative 4. Okay, so of these polynomials, it is not considered to be a polynomial if the exponents aren't whole numbers. So if you had like x to the 1/2 power, that would not work. If you have a variable that's contained in the denominator, like 1 over x, that is a function. It's a reciprocal function. This is like the boomerang thing, but it's not a polynomial. And then no variable under a radical, so you can't have the square root of x. Even though that is a function, it's not a polynomial function. So those are just some no-nos for polynomials, okay? Now, of the polynomials, there are special names for ones that are first degree, second degree, third degree, fourth degree, etc., right? So a first degree is a linear. These are all polynomials, but more specifically, he's linear. Second degree is quadratic, third degree is cubic, fourth degree is quartic, and then you have quintic, and anything after 6 is just like a 6th degree polynomial or a 7th degree polynomial. It's not like septic, even though whatever. Anyway, septic, that's not a thing. It's like 7th degree polynomial, 8th degree polynomial, whatever. Okay, so there's that. All right, now they're going to jump right into dividing polynomials, okay? So you guys probably did long division back in elementary school when you did like, I don't know, 348 divided by 2, right? 2 goes into 3 once. Here's 2. You subtract 1 and then you bring the 4 down. 2 goes into 14 7 times. 14, you subtract, that's a 0. You bring the 8 down and that goes in there 4 times and it's 174, right? So this is a very similar concept to that, but we are dividing polynomials, okay? So we probably did this in Algebra 1 before, but, or Algebra 2, sorry, Algebra 2. But this is just kind of a little bit of a refresher, so I'm going to go kind of a little slow. The stuff that you're dividing goes on the inside, and then what you're dividing by goes on the outside, just kind of like how we did here. But another thing to consider is that you need a placeholder for everything. So notice here I have an x to the 4th power, I have an x squared, an x, and a number, but I do not have an x to the 3rd power. I still need to put a value in there, so I put 0x to the 3rd power to hold its place, okay? So we're dividing by x minus 2. So what we're going to do is the first thing that we say is, like here, how many times does 2 go into 3? How many times does x go into 3x to the 4th? Or basically, what do I need to take times x to get 3x to the 4th? So if I multiply by 3x to the 3rd power, this is a really fat marker, and I'm trying to write in a really little spot, so I'm sorry. 3x to the 3rd power times x will give me 3x to the fourth power. We kind of ignore the negative 2 for right now, okay? So we're going to do this. We're going to multiply back through. So 3x to the third power times x is 3x to the fourth power. That's what I want to have happen. Now I'm going to consider the negative 2. So 3x to the third power times the negative 2 is negative 6x to the third power. Okay? Now, this is the very, very most important thing. After you multiplied the 2 and put him down here, right? 1 times 2 was 2. You subtracted, right? You kind of like flipped the sign. So 3 minus 2 gave you 1. So what we have to do is the same thing down here. We have to go down here and change this to be a minus, and if it's already a minus, you change it to a plus, okay? And then I'm going to add, so these two will cross out as they should. If it doesn't, then I did something wrong. 0x to the third power and 6x to the third power is just 6x to the third power, and then I'm going to drop my next term down. So the negative 8x squared is going to come down, okay? And then I start the process over again. So I look to see, what do you multiply by x to get 6x to the third power? And that's just going to be 6x squared. And it's a positive 6x squared, okay? And then I multiply them back through. 6x squared times x is 6x to the third power, okay? 6x squared times negative 2 is negative 12x squared. All right, I'm going to run to the bottom here, and that's fine. I'll just type it, or I'll just write over top of it. Okay, next thing, flip my signs. So I need to make this guy negative, and since this guy's already negative, I make him plus, and then I combine I combine my stuff. So this guy's going to cross out like he should. If he doesn't, I did something wrong. Negative 8x squared plus 12x squared is 4x squared. And then I drop my negative 11 down, minus 11x. Okay, so that's 4x squared minus 11x. I just dropped that down. If I'm going too fast, feel free to pause this video if you need to. That's okay. All right, so 4x squared is the next number that I'm looking at. Okay, I don't really look at the 11x and I don't really look at the 2. I'm looking at x compared to 4x squared. Okay, so what do I have to multiply by x to get 4x squared? And that is just a positive 4x. Okay, if I multiply that back through, 4x times x is 4x squared. Okay, 4x times negative 2 is negative 8x. Okay, so now I flip the signs. So I go back through. 4x squared minus 8x will become negative 4x squared plus 8x, and then I'll combine like terms. So this guy will cross out like you should. Negative 11x plus 8x is negative 3x, and then I'll drop my 1 completely down. Okay, so plus 1. Okay, one more time. So now we look and say, what do you multiply by x to get negative 3x? Okay, so I go back up to the top. What do you multiply by x to get negative 3x? And that is just negative 3. Negative 3. Negative 3 times x, multiplying them back through, is negative 3x. Okay, negative 3 times negative 2 is positive 6. So I'm going to do plus 6. But then I have to flip the signs. So negative 3x plus 6 is going to become positive 3x minus 6. Okay, the 3's are going to cross out, and then I have 1. Is that minus 6? Yeah, 1 minus 6 is negative 5. Okay, now there's nothing that I can't repeat this process over again. There's nothing that I can multiply by x to get 5, right? Because he doesn't have an x on him. So that's what's going to be my remainder. So I would have, since this is a negative 5, I'll do minus 5 over x minus 2. Okay, now you really could do this as a remainder. You could do plus negative 5 over x minus 2. Either way you want to do it. So this on the end is correct, this on the end is correct. But this is your whole entire answer, right? I don't know what I just did. Let's go back. There we go. This entire thing is your whole entire answer. So there's that. Okay, so that was long division. All right, most people like synthetic division a lot better. So this is synthetic division. Okay, and there's a time and place where long division and synthetic division should be used. Synthetic division, although a lot of people think it's easier, can only be used in certain situations, and I'll show you what those are here in just a second. So we are dividing this big long thing right here by x plus 3, okay? So when you're doing synthetic division, you're going to set this box up, like your division box, like upside down, kind of. So he goes, synthetic division, he goes this away. He goes that away, okay? And your coefficients, or your numbers out in front of each one, are going to be listed up here at the top of your box, okay? Now make sure that if you don't have a place value, put 0 in there. So let's see, I have an x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and then a number. I don't have to put any zeros in, okay? So now I just start with the coefficients out in front. So this is 1 x to the 5th, so I put 1 here. 5x to the 4th, so I'm going to leave some space and put a 5. 6 is the next number. -1 is the next number. 4, and then 29. Okay, so I leave those all the way off over here. Now, the number that you're dividing by, or the part that you're dividing by, is going to go out here, except, this is the kicker, x plus 3. I'm not going to put a positive 3 out here on the side. I have to set x plus 3 equal to 0, which means that x equals -3. So it's kind of like using the opposite sign of this guy. And I'm going to put -3 on the outside. And the reason why we have to do that is because over here we switch the sign of each one, right? After we would multiply it back through, we'd flip the sign. And you don't do that over here. You only do it once when you switch that to a -3. So switching this one thing kind of switches your signs all the way through, okay? So this is how your synthetic division works. So what you're going to do is the very first step, you drop this number down, whatever it is. You drop that number down, okay? And then you're going to put a number in this box, and the number that goes in this box is -3 times this number down here, which is 1. So I'll put little tiny work in here, -3 times 1, which is -3. Okay, so this is the number that goes right here. And then from there, I add these together. So 5 and -3 makes 2. And then I repeat the process again. So -3 times 2, -3 times 2 is -6. And 6 and -6 together added makes 0. And then I multiply again. -3 times 0, -3 times 0 is 0. So -1 and 0 makes -1 when I add them. Okay? And then I go again. -3 times -1, -3 times -1 is a +3, and 4 and 3 added together makes 7. So you're constantly doing the multiply, add, multiply, add, multiply, add. Okay. Last one, -3 and 7 makes -27. No, -21. Sorry, -21. And 29 and -21, when I add those together, gives me 8. Okay. So now I need to write this as a polynomial, so it's pretty easy. If I started with x to the 5th power and I'm dividing by an x, what's going to happen is this x to the 5th power is going to become x to the 4th power, because if I divide an x out, it'll be x to the 4th power. So each one of these, the coefficients are going to start with, this is going to be x to the 4th power. And then since this is +2, I'll put +2. This guy's going to be x to the 3rd power, +0, x to the 2nd power, -1, x, and this is a +7. Now 8, I put him in a box because he's going to be your remainder. So if I rewrite this out, because I'm going to get rid of this 0 in here, I will have 1x to the 4th power, or just x to the 4th, plus 2x to the 3rd. I'm going to leave that x to the 0, or that 0x squared off, and I'm just going to do -1x plus 7, and then plus 8 over, this is how I write my remainder, 8, and I was dividing by x plus 3. So I put 8 divided by x plus 3 in there, and this is my solution for my synthetic division. Okay, so there he goes. All right, now, so polynomial division, or long division versus synthetic division. A lot of people like synthetic division better, but you can only use synthetic division if what you are dividing by is x plus or minus something, right? So in this next one down here, if we are trying to divide this thing right here by 2x squared plus 1, we can't do it using synthetic division. We would have to do long division, okay? So there's kind of the struggle there. All right, so let's see. Let me go to the next page and see what we have coming yet. Okay, all right, we're almost done. So this one's going to take a little bit of time. So this one we have to use long division on, okay? All right, and this one's going to be kind of weird again because I'm going to make my box here. Oh man, I can't draw. So 6x to the third power. I got to make sure I'm putting in any zeros if I need to. Minus 4x squared plus 3x. I don't have to put any zeros in, do I? Minus 2. So I have an x to the third, x to the second, x, and then a number. All right, now, here's the weird part. 2x squared plus 1. I don't have an x in there, so I also still need to do 0x here as well. So if he doesn't have a 0 in there, if he doesn't have a placeholder, you have to put a placeholder in even for the part that you're dividing by. Okay, otherwise it's going to screw stuff up. Okay, so I'll try to go through this one a little bit fast. So what can we multiply to get 2x squared, or what do we multiply by 2x squared to get 6x to the third power? So if I'm looking at the numbers, what do I multiply by 2 to get 6? That is 3. Okay, and what do I have to multiply by x squared to get x to the third power? Is just an x. Okay, so now let's check that by multiplying it back through. So 3x times 2x squared, that will make 6 and x to the third power. That's what I wanted. Now I do the same thing again. 3x times 0x. Okay, 3 times 0 is 0. X times x is x squared. Okay, and I'm just going to go ahead and write them as a positive 0x squared, whatever. Okay, then the last piece, 3x times 1 is 3x. So I put plus 3x. Okay, and then I go back through and I flip the signs. So I'm going to change this to minus. This is going to be minus now, and this one's going to be minus now. If it's already minus, you change it to a plus. And so I'm going to combine my like terms, and I have this going on. So 6x to the third, he cancels out. Okay, now this is weird. Negative 4x squared minus 0x squared, that's still negative 4x squared. But look at what happens here. 3x and negative 3x. Okay, that's okay. That's okay. They can cross out. We'll just put plus 0x, just so we have that placeholder in there. And then I'm going to put minus 2. Okay, so now I have that. And let's do this maybe one more time. So what do I multiply by 2x squared to get negative 4x squared? Okay, so 2 to get negative 4, I would have to multiply by negative 2. Okay, and then x squared, to get x squared, I don't need any more x's, so I'm just going to multiply by negative 2. So negative 2 times 2x squared is negative 4x squared. Okay, and then negative 2 times 0x is still 0x. And negative 2 times 1 is negative 2. All right, and then, I need to flip the signs first, right? Flip the signs. So this negative 4x squared will become positive 4x squared. This will really become negative, but it doesn't really matter because it's 0 anyway. And then negative 2 will become positive 2. Okay, so negative 4x squared and positive 4x squared, those are going to go away. The zeros are going to go away. Negative 2 plus 2 goes away. So I really have like a remainder of 0. And if I have a remainder of 0, then that means that this 2x squared plus 1 goes in there evenly. He's perfect, right? Like up here, 2 went into this number evenly because I didn't have a remainder, right? I did not have a remainder on the end there. So it says determine whether this guy is a factor of this one. Well, if he goes in there evenly, yes, he is a factor. So yes, he works out perfect. He is a factor. Okay, so that's what we were trying to determine. And again, we have to do that with long division because it only works with synthetic division if you have like x plus or minus just a single number, right? No x squareds or any weird thing, okay? All right, let's go to the next one. These next two go really super fast. So this is a way of checking your answer, and always do this on tests and on homework, just to check your answers. So it says find the remainder when you are dividing this big, huge, long thing by this thing, okay? Now, heaven forbid I actually have to divide that, like x to the 79th power. Then I would have to do plus 0x to the 78th power, plus 0x to the 77th power, etc., right? All the way down until I get to the end, and I don't want to do that. I just want to find the remainder, okay? So, finding the remainder, if we go back to this guy, the remainder here was -5. The remainder here was 8. Is there a way of finding that without actually doing the long division? Yes, there is, and here is how you do it. So x minus 1, kind of like in synthetic division, you take x minus 1 and you set it equal to 0. And x is equal to 1 then, okay? So we're going to take that x is equal to 1, and I'm going to plug it into this equation right here. So this is 1 to the 79th power plus 3 times 1 to the, I can't even see that, 24th power. It doesn't really matter because I'm doing it by 1, but, and then plus 5, okay? So 1 to the 79th power, 1 times itself 79 times is still just 1. So we're going to cross them out, we're going to put 1. 3 times 1 to the 24th power, well 1 to the 24th power is still 1 also, but then you take 3 times 1 and that's 3, and then plus 5, and that number is 9. So what this means is that when we plug that guy in to this equation, what would happen if I would take this thing and divide by x minus 1, we would get 9 as a remainder. 9 would be my remainder, okay? All right, so same thing again, find the remainder if we were dividing by x plus 2, okay? So x plus 2, if I set that equal to 0, x would be equal to -2. Okay, so I'm going to plug -2 into this equation here. It's going to be a little bit longer. 3 times -2 to the 4th power minus 8 times -2 squared plus 11 times -2 and then plus 1. Okay, so -2 to the 4th power. Let me get a different color here. -2 to the 4th power is 16. I believe, yes, 16, positive 16, and 3 times 16 is 48, okay, minus -2 squared is 4, is a positive 4, and -8 times 4 is -32, okay, then we have 11 times -2 is -22, and plus 1, okay, so 48 minus 32, if I do those two things, 48 minus 32, that will be a 16, and then 16 minus 22, that is -6, plus 1 is -5. So my remainder, if I were to divide this whole thing by x plus 2, I would get a remainder of -5. Okay, now this going forward is going to be important because what I can do is like we did over here, I can determine whether, one of these guys goes into here evenly, because if the remainder is 0, then I know that he's a factor, right? He goes into there evenly if I don't have any remainder or don't have any left over. So we know from these two that this is not a factor of this because I do have a remainder, and this is not a factor of that because I do have a remainder. Okay, they would be factors, or they would go in there evenly if both of those numbers were 0, or one of the numbers were 0, right? Okay, so if this was 0, this guy would go in there evenly, and same thing with this one over here. So that's going forward what's going to be the main point, okay? Because I want to cheat. I don't want to have to do long or synthetic division every time to figure out if he's a factor or not. So there's that. That's how that works. And go ahead and start on the homework assignment because some of this long and synthetic division takes a little bit of time, but we're going to finish these notes on Friday, okay?